6-4 is all about adding and subtracting polynomials. So before you can add or subtract polynomials, it would be important for you to know what is a like term. So add this to your notes. Here's the definition for a like term. So like terms have the same variable string, raised to the same exponents. So for instance, if you look at example 1 right here, you notice that all three terms have an m as their variable. So they all have the same variable string, however, the exponents are not all the same. So they look alike, but they're not all like terms. It would be like looking at apples. Some apples are red, some apples are yellow, some apples are splotchy, some apples are green. They all look like apples, but they are different. And so what you've got to do is determine which variables are raised to the same exponents. So these two terms both have m's and they're both raised to the same exponent. So 15m to the third and 2m to the third are like terms, whereas the 6m squared is not like those, so it is not like the others. So once you identify which are like terms, all you do is add the coefficients. The variable string does not change, it stays the same. So if I have 15 of these and I add 2 more of these to it, I've got 17 of those total. So 15m cubed plus 2m cubed is 17m cubed. And then you don't have a like term to add to the 6m squared, so it's just plus 6m squared. And so that is the sum of those like terms. So look at example 2. Let's determine what's a like term. So we're going to start with 2x squared. So you're going to look at the polynomial and determine which other terms also have a 2x squared. This term here has an x squared. It doesn't have to have a 2, it just has to have an x raised to the second power. So those are like terms. And then the next term is 5, and it's a constant. All constants are like terms, positive or negative. So this 12 is also a constant, so it's considered a like term to any other number, positive, negative, or 0. And so when you add 2x squareds to a negative 7x squareds, 2 plus a negative 7 is a negative 5x squared, and then 5 plus 12 is 17. So we have a plus 17. It does not matter which order you write your terms in, unless you're told that you have to put it into standard form. So you could have had 17 minus 5x squared. So long as the sign stays with the term, you can write it in whatever order. So you could have written 17 minus 5x squared. All right, let's look at the third example. So this time we have decimals. That shouldn't matter because the coefficients don't matter. What matters is the variable string. So as you can see, they're all y's raised to the fifth. In fact, they're all raised to the fifth power. But this one has an x as a base, so it is not a like term to these three. So this is a like term, this is a like term, and this is a like term. The 5/10 x to the fifth is unlike the others. So off to the side, I tend to like to write, add the positive numbers first, then add the negative numbers, and then combine those. So this one you don't see a coefficient. If you don't see a coefficient, it's understood that the coefficient is 1. In this case it's positive 1 because it's a plus y to the fifth. So off to the side, I'm going to take 1.0 and add to it the 0.9, which gives me 1.9. Then I am going to subtract the negative 0.4. Really, I'm adding a negative 0.4, but when you add a positive and negative, you subtract and keep the sign of the larger. So we end up with a positive 1.5 as a coefficient because the 1.9 is bigger than the 0.4. So our answer is positive. So our first like term is 1.5 y to the fifth, and then plus 0.5 x to the fifth. The last example on this page, they all have x's and y's. But are they all raised to the same exponent? The x's are, and the y's are all to the first power. So all three of these are like terms. So what is 2 minus 1? It's 1. Then 1 minus 1 is 0. So they all cancel each other out, and the final answer is 0. And yes, you do have to put 0. You can't just put nothing. Next page. So on this page, example 1, the only difference between this page and the previous page is now we have these grouping parentheses right here. But because there's a plus in the middle of the two grouping parentheses, it really doesn't have any bearing on the problem. We're taking this and adding this to it. So you can drop the parentheses and then collect like terms because the plus in the middle doesn't have any effect on the problem. So you've really got 2x squared minus x plus an x squared plus a 3x and minus a 1. So I'm going to start with a 2x squared. I'm looking for any other variables or terms that have an x squared. So here's an x squared, and there are no more. So then I'm going to look at this term. Its variable is x to the first. So the only other term that also has a variable of x to the first is 3x. And then finally, we have our constant 1, negative 1 actually, and it's the only constant, so it's its own like term. So then let's collect like terms. Excuse me. So just look at the coefficients. 2 plus 1, remember this has a coefficient of 1, because you can't see it, it's understood to be 1. So 2 plus 1 is 3x squared. Next we have a negative 1 and a positive 3, which gives you a positive 2x. Remember that variable string does not change. And then there's nothing to collect with the constant, so we just write down a minus 1. And there's our final answer for that one. Same thing with example 2. This plus sign has no bearing on the problem, so we can just drop the parentheses and collect like terms. So now I'm looking for the same variable strings. So I'm going to start with this AB. So this is my first term. Are there any other terms with an AB? Nope. Yep. So these are alike. And in fact, if you notice, this is a negative 2 and this is a positive 2. They're opposites to each other, so they cancel each other out. So you can go ahead and just cross them out. Then that leaves us with B as the next term. There is no other B term. And then our final term is A, and there's no other term that combines with A. So we end up with a positive B plus an A. The last problem on this slide, again, this has no bearing on the parentheses, so we can just drop the parentheses, the grouping parentheses, and just collect like terms. Whoops, let's erase that. Okay, so then let's start with our first term. the 4b to the 5th, and we'll collect any other b to the 5th. Here's another one, and here's another one. So there's 3 different b to the 5ths. Our next term is the variable string b. So there's one, and there's one. So there's 3 of each. So if I add the coefficients, 4 plus 3 is 7, and then 7 minus 7 is 0. So these all cancel each other out. So there's no b to the 5th left. That leaves us with 8 plus 6 is 14, plus 1, because remember that coefficient is 1, gives us 15. So we have 15b as our final polynomial. Next page. So on this page we're actually subtracting. So remember when we subtract, we change everything to an addition problem by keep, change, change. Keep whatever comes in front of the subtraction sign, change the subtraction to addition, and change the sign of anything that follows it in parentheses. So when we do keep, change, change, we're going to keep the first parentheses, change subtraction to addition, and then we're going to change the sign of anything that follows it. So essentially, I am distributing this negative into the parentheses. I'm really multiplying a negative 1 into these parentheses. So I end up with 2x squared plus a 6, and then we don't write double signs. We're not going to write plus a negative. This is a negative 4x squared. So minus 4x squared. So we don't write plus minuses. A plus minus is going to equal a negative sign. And we don't write minus minuses. That's going to equal a positive, because if you have a minus minus, you'll add the opposite, so that'll be a plus plus. So just remember this. No double signs. And then now we're ready to look at like terms. So I'm going to start off with the 2x squared. This term also has an x squared, so they're like terms. And then the constant 6 is its own like term. So now you can add the coefficients. We're doing just what we did with the last 6 problems. 2 minus 4 is a negative 2. The x squared does not change. And then tack on that variable plus 6, and there's your final answer. Example 2. Again, we're going to do keep, change, change. So we're going to keep this as is, it doesn't change. The subtraction sign changes to addition. And then we're going to change the sign of everything inside. So you could do one of two things. You could do plus, minus, so that should keep, change, change. Or you could just look at this and go, okay, I'm going to take this negative and I'm going to multiply it. Really, you're distributing a negative 1 to everything in parentheses, because technically the number that's in front of the parentheses is a negative 1. And this is what I prefer to do. It's just easier than doing plus and then changing all the signs. So we have a to the 4th minus 2a minus 3a to the 4th plus 3a minus 1. So multiplying everything here by the negative 1 that's in front of the parentheses changed the sign of each of these to its opposite sign. And now you do what we've just done when you add. You're just going to look for like terms. So here's an a to the 4th. Here's another a to the 4th. Our next like term has a variable string of a. So there's another a. And then finally we have a constant of negative 1. So to collect those like terms, I've got 1, because there's a 1 in front of here. 1 plus a negative 3 is a negative 2, a to the 4th. And then a negative 2 and a positive 3 is a positive 1a. We don't write coefficients of 1. And then you tack on your constant of negative 1. And let's look at our final problem. So again here, this is going to stay the same, but but I'm going to take this -1, which is really a -1 in here, and I'm going to distribute it to everything that's in parentheses by multiplying. So the first parenthesis stays the same, but the second parenthesis becomes a -1 times an x squared gives me a -x squared, and then a -1 times a -4 gives me a +4. So then our first term is an x squared. So this is another x squared. Our next term has a variable string of x. There's no other variable string with an x. Our next term is a constant, and we do have one more other constant. So focus on the coefficients now. 3 minus 1 is 2. So we end up with a 2x squared. Then we have -2. Well, it's its own like term. There's nothing to combine with it, so we're just going to write it down. And then finally our constant, 8 plus 4 gives us a constant of 12, so +12. And that is our final answer.